Good morning. So today we're going to learn about Newton's third law of motion. Don't forget that you have your notes. This is page 14 in your packet, and you are going to highlight the underlined words and answer the questions. So we'll go through those as we go. So we're going to start with Newton's third law. Newton's third law is about momentum. And so it says that a force cannot exist alone. They're always going to exist in pairs. And this is a very famous thing that we've heard lots and lots of times. So there is an equal and opposite reaction for every force. So for every action, there's an equal and opposite reaction. So like this guy right here on the skateboard, he's exerting an action force down. Gravity's pulling him down. And the reaction is the ground is pulling him upward, pushing him upwards. Think about a swimmer. Action forces produce a motion when a swimmer takes a stroke. So the action force is they push back in the water. The reaction is that the water pushes them forward. Or like a hammer and a nail. The action force is the force of the hammer on the nail. The reaction is the nail pushing back on the hammer. If you didn't have that reaction force, the nail would always just go straight in. All right, so what about momentum? Momentum is the product of an object's mass and velocity. If an object has large momentum, it's hard to stop. So think about a semi and a smart car. The semi is larger, it has more momentum. So if it were rolling down a hill, it'd be harder to stop the semi than the smart car. All right, so let's look at this. On your notes, it says, using Newton's third law, explain what's meant by action and reaction forces. I have that force is exerted by an action force. The reaction force is exerted back. Second question says, explain how Newton's third law of motion is at work in a car crash. So the action force is the car hitting the object. The reaction is the object pushing back. So if you hit something in your car, there's going to be a reaction of that car pushing back. Of the object pushing back on your car. All right, so let's talk about the four universal forces. We have electromagnetic forces, the strong force, the weak force, and gravitational forces. All of these forces act over a distance, so it means you don't have to be touching them in order for them to be acting. Gravity, that's an attraction between two masses. We talked about this yesterday. Newton's law of gravitational universal gravitation states that every object in the universe attracts every other object. Okay, so there's a pattern to everything. The gravitational force between two objects is proportional to their masses and decreases as the distance between them increases. So gravity is the weakest universal force, but it is the most effective over long distances. So what that means is you may have a force acting between two objects, but the farther they get away from each other, and the smaller their mass is, the less it's going to affect them. So centripetal force, this is a force that keeps things moving in a circle. So when you're on a roller coaster or you're slinging a bucket over your head with water, you have centripetal force in action. It's also the things that keeps the moon in orbit around the earth. Okay, so you've got lots of centripetal forces, but it uses inertia, okay? Your mass or your size or your ability to resist rest as you move in a circle. Because if you have a tub of water and you're slinging it above your head, the more water you have in there, the easier it is to hold it inside the bucket. All right, so let's look at these last two questions. What happens to the gravitational force as two objects increase the distance between them? The gravitational force decreases as the distance increases. And then I drew a person slinging a softball, okay, because they do this fast pitch softball where they sling it in a circular motion to build up momentum. All right, so what I want you to do is yesterday you were supposed to look at page 16, all right? So most of you have already looked at page 16 and done that. Those four questions should be answered. Use your triangle at the top to answer those questions. Now, today what you're going to do is you are going to answer the questions on page 17 about Newton's second law. Okay, you're going to use force equals mass times acceleration. So here's your triangle that you've got right there. All right. And then you're going to flip it over and you are going to answer these questions about gravity. Now, this may be too much for right now, so if it is, just skip it and come to this because we are going to do pages 19 and 20. Remember, weight equals mass times gravity, okay? Weight equals mass times gravity. So in your triangle, when you're drawing this, your triangle would look like weight is mass times gravity. So I want you to define mass and weight. If you need help with that, it's in your notes. And then it says, describe what will happen to the mass and weight when you go to the moon. Well, we know it, weight would decrease and mass stays the same. You can't change your shape or your size, but your weight would change because gravity changes. So why is that? Because there's less gravity on the moon. So let's do one together, and I think you can figure the rest out yourself. It says find the weight of a 60-kilogram astronaut on Earth. Now we talked about earlier, and it tells you up here, that your gravity on Earth is about 9.8 meters per second. So we're going to put about 10 meters per second squared. That'll make it easier for us. So we want to know our weight up here, and we know our mass. We know that goes in the bottom left, 60. And then gravity, we just said on Earth would be 10. And we know that 60 times 10 is 600. And our weight is going to be in newtons because it includes the force of gravity, okay? Now it says find the weight of the same object on a planet where the gravitational attraction has been reduced to 1/10 of the Earth's pull. Okay, so let's do that. We still want the weight, so I'm going to leave that blank. And we want gravity to be 1/10. So 1/10 of 10 is 1. We want the weight to be the same, 60. 60 times 1 would be 60 newtons. And you could tell that because 60 is 1/10 of 600. So I want you to go on and I want you to do 5 through 7, all the way down to the bottom. Be careful about whether we're on Earth or on Pluto. Like on Pluto, they're wanting you to find gravity. So in your triangle, you would leave gravity blank. You would put your weight up here. And you would put your mass right here. And remember, if one's on top of the other, you divide. Okay, so just use your triangle, put things in there, and it will all work out perfectly. And I will see you tomorrow.